Hey y'all. Uh-oh. Where's my, oh, here it is. Sorry, I always get sometimes confused. All right, so today's lesson is similar polygons, and I told you to take out some pages from your book. I'm starting on page 114, but your first page is gonna look like this. Properties of similar polygons, lesson 1, which is 113. We'll turn it over to the back. There. Okay, page 114. So similar polygons. If two polygons are similar, then there are two things you need to know. So these two things are important, and I'm going to ask that you write it again over here so you're really paying attention. Their corresponding angles are congruent. So one important thing about similar polygons, let me check. I feel like it keeps focusing. Okay, no. All right. Corresponding angles are congruent. And that's kind of like parallel lines cut by transversal. Corresponding angles are congruent, or they have, sorry. Corresponding angles are congruent. So if you have similar polygons, similar triangles, similar rectangles, the angles that are corresponding are going to be congruent. The second important thing about similar polygons is the corresponding sides have proportional ratios. Corresponding sides have proportional ratios. Basically, the corresponding sides are proportional. That means if, let's just say, a triangle was doubled, that means all the sides are going to be double. All the three sides of the triangle are all going to be proportional in their change. You're not going to double two sides and then triple a side. It would be whatever the ratio is consistent for all sides. They're all proportional. That's how you can tell if polygons are similar. And here's a vocabulary word right here. Polygons that have the same shape are similar. And we use this symbol for similar. It's just like one squiggle. So when you see that, you know that means that the shapes are similar. So right here it says triangle ABC is similar to triangle XYZ. And when the letters are matched up like this, see the word matched, those are corresponding parts. So A corresponds to X, and B corresponds to Y, and C corresponds to Z. So that you can see it up here, A and X, they're congruent. B and Y, because those are angles, they're congruent. And then C and Z, because again, their letters match up. Their letters match up. So angles are congruent, sides are proportional. So here's an example. Rectangle JKLM is similar to rectangle RSTU. What do you know about the corresponding angles and sides? Now, of course, it's done for you, but I'm going to explain what you're expected to do. What do you know? What do you know? So there's two things. We know something about the angles and the sides. So let's start with the angles. And I'm showing you what you're going to answer. What do we know about the corresponding angles and sides? Let's start with the angles. Again, you could just go in order J and R. And if you look, J and R are in the same place. They're matching, they're corresponding. So angle J is congruent to angle R. That's one thing you know. So this is what you're expected to answer. Which angles are congruent? K is congruent to S. Angle K is congruent to angle S. Angle L is congruent to angle T. And then angle M, the last one listed, is congruent to angle U. So that's half of your answer. That takes care of the angles. The angles are congruent for similar polygons. Now it's asking about the sides. The sides we wrote are proportional ratios, and a ratio is a comparison of two numbers. So we are going to talk about the ratio. Now, if you look at these two rectangles, we have 6 to 9, 3 to 4.5, 6 to 9, 3 to 4.5. And we are going to start with whatever is listed first. If you look from rectangle JKLM to RSTU, you can see that it got bigger. The rectangle got bigger. that means that whatever I multiplied by, it was bigger than 1. So we're just going to start with, to show that the sides are congruent, we're going to just start with JK, because it's right here. So line JK corresponds to line RS. And that would be your ratio because it's JK to RS. And again, all the ratios are proportional. All of them are equal, all the ratios. So then the next one, I would just go KL, because we're just going around the rectangle. KL corresponds to ST. And then I would go LM. And you see, I could even use here, LM corresponds to TU. And then my last ratio that I'm setting up is going to be MJ, because I need to keep consistent, and then UR. And the reason I'm setting up a fraction is because these are ratios and these are all proportional. So this is what is expected for you to answer when it asks you, what do you know about the angles? And then we did the sides. All right, so you try this one. You have two similar triangles, and it says, what do you know about the corresponding angles and the sides? So I want you to answer two parts. What do you know about the angles, and then what do you know about the sides? Press pause, and then press play when you're ready. See the answer. All right, so you can see in this triangle from ABC to FGH, it looks like everything was doubled as far as the sides. Now the angles are congruent, so 90 and 90, this one C to H, and then B to G. So let's talk about the angles first. Angle A is congruent to angle F, and that's easy to see because they're both 90. Angle B is congruent. See, this has one arc in it. This one has one arc, so those are congruent. And then angle C, it has two arcs, is congruent to angle H. So that's first half of your answer. That's what we know about the angles. Now the sides, remember the sides are proportional. So I'm just going to start with AB. I'll start with AB. So AB is going to be proportional to FG. And BC is going to be proportional to GH. And CA is going to be proportional to HF. All right, and so those together are your two answers. So when you're asked, what do you know about the angles and sides, you know that the angles are congruent and the sides are proportional. All right, so now let's go to page 115. And now we're going to actually do some math. Determine missing measures. Scale factor, you need to underline, highlight, box the word scale factor. Is the ratio of the lengths of two corresponding sides of two similar polygons. So the scale factor is what happens from one polygon to the next. Like on that last example, from 4 to 8, 3 to 6, and 5 to 10, can you figure out what the scale factor is? What happened to each side? And hopefully you saw it was multiplied by 2, so the scale factor would have been 2, because that's what happened from ABC to FGH. All right, so now we're going to determine a missing side. Quadrilateral UVWX is similar to DEFG. Determine the missing measure. So we have measures here, 8 to 12, 6 to 9, and then we have 10 to the missing measure. So the best thing, in my opinion, there's a couple of ways, but the best thing to do would be to set up a proportion, because you know proportion. You know that these are proportional. So we're going to set up a proportion, which is two equal ratios. And I'm just going to go ahead and start with the one that we're missing because it gives us a starting point. So we're missing VW right here. VW. This corresponds to EF. So that's why it's important to know the corresponding part. So we're going to put 10 underneath. Now, M comes from the big shape. Do you all see? M comes from the big shape. So we need another value on the big shape. And you can choose 9 or 12. It doesn't matter. So I'll just choose 9. And then what corresponds to 9 is 6. And if you've forgotten how to solve a proportion, you're going to cross multiply. So 6 times m is 6m. 9 times 10 is 90. And then we divide those sides by 6, and m equals 15. So the missing side is m equals 15. Okay? And then the rest of this problem showed you how to do it two ways, to find the scale factor or to set up a proportion. I think setting up a proportion is easy, but finding a scale factor is very good. To find a scale factor, you would just set up the proportion, and then you would simplify. Okay? So, last one. All right, page 116. All right, find the missing measure. All right, I'm going to do B with you, and then C is going to be a U try. All right, so WZ is right here. WZ. Where is, okay. So we're missing WZ. We're going to call this, we'll call this B. So I need to set up my proportion, B, and B corresponds to AD, which is 13. And B comes from the big shape. You know, I'm not trying to trick you. This is just bigger. So I need another number from the big shape, and I'm going to use 15 because that's the, well, I guess I could use 24. But does it really help me to use 24? Is there something that corresponds to 24? No, there's not. So it's best to use ZY, which is 15. And then what corresponds to ZY would be 10. Okay, cross multiply. B times 10 is 10B. And 15 times 13, oh my goodness. 15 times 13, I don't know, 195. And then we divide both sides by 10, and we get 19.5. So our answer to B is 19.5. It doesn't give any units, so 19.5. Again, I set up a proportion, and then I cross multiplied. Letter C is a U try. So U try, pause, and then press play when you're ready to see the answer. All right, so C is AB, so I'm going to call that C. I'm going to set up my proportion. I like to just start with the missing unit. It just gives me a good starting point. And C corresponds to 24. And then C comes from the small shape. So I need another number on the small shape, and I'm going to use 10. And the reason I use 10 is because I can just see that 10 and 15 correspond. So we're going to cross multiply. 15C equals 240. Then we would divide both sides by 15, and C equals 16. And then we can always check and make sure our answer makes sense. C is 16, and so it has to be less than 24, and that makes sense. We got, what did we get? B was 19.5, and it's bigger than 13. Another way that you could check yourself is you could check that they're proportional. 24 over 16, does that equal 15 over 10? And if you reduce them all, you divide this by 8, you get 3 over 2. And if you divide this fraction by 5, you get 3 over 2. So see, my proportions are equal. So that's what it means. If you have similar figures, your sides are proportional. All sides are proportional. Okay, I just need to check my time. Hold on one second. Okay. All right, so let's see, guided practice. We'll probably start here in class because these questions are just like the ones. And if you feel like you need more practice, then you can try the guided practice and then let me know. All right, see you soon.